to my presentation. While I'm based in Belgium, I'm also a proud Irishman, and I'm going to be very careful not to say anything about rugby today in this presentation. But what I want to do is talk to you a little bit about some of the ideas we have around precision livestock farming and where it goes and what some of the challenges are and maybe where the future will go. So hopefully you can get some idea. You know, I live at home with 2 teenagers, and they hate the fact that I'm a researcher because I bore them every time I talk to them at the dinner table. And but one day I got a quite interesting surprise. My oldest son showed me this tool. He said, "Dad, yeah, what you do now, it can be done completely on the computer. It's possible to simulate the real-life farming conditions, choose your chickens, go out and view the chickens when they're being produced, follow them up, and feed them, go and order your feed, and then plan out your farm, and so on and so forth." And he thought, "Oh, well, this is a fantastic area you're in. This will be the future, right, Dad?" And of course, I said, I started on with the boring story then. I said, "No, I'm sorry. This is a simulation, and indeed, times are more challenging for farmers. Maybe we'll get there. But we're talking about precision livestock farming, making things into a digital representation of reality. So maybe there will be a blend in the future of this." And he seemed quite interested. Maybe his eyes were glossing still over, but I hope that maybe he will see some interest in the future in it. But of course, yeah, the times are challenging for livestock producers. It's clear with avian influenza, with swine flu, that there are many disease challenges looming that cost a lot economically to the production system. Welfare, as Virginie discussed there, is a big challenge, and EFSA are trying their best to improve the situation. And of course, farmers are also trying to deal with these extra regulations that are going to come down the line. And of course, environmental challenges are there. And that's something I'll discuss a little bit more later on. And not only these external factors, but there's a lot of internal factors, like the aging population. The aging farming population is a big challenge. We see it in Belgium, that the average farmer is in their mid-60s, and the follow-up in terms of family members interested are reducing. So there needs to be some consideration of what will the future be for livestock farmers. We see the protests, and for sure this isn't looking well for young farmers. And it all ends up with this. This is the same old graph where we see the industry is consolidating, numbers of farmers are reducing, meanwhile the number of animals per farm increases, and therefore we give rise to this more factory production perception. And also because we're becoming more dense in our production systems, we have localized pollution. And we see that in Flanders. That's a picture of Flanders. And in the north of Flanders, which is the region of Belgium that I'm based, we see a heavy population, and therefore pollution and so on is linked with that. But what I want to say is, livestock farming, it doesn't matter whether it's chickens or whether it's cattle or pigs, there is a kind of equation that is there that we all try to follow. And it's related, it's kind of the impact is equal to the efficiency times the production. When I'm talking about production, I'm talking production density and efficiency of FCR, or feed efficiency, and so on. And the idea is that if we increase our efficiency, in other words, our resource efficiency, our use of resources, that we improve our economic impact. And that's what the farmers will try and do. It's a win for the farmers, of course. And the thought is that, okay, if you increase your efficiency, you will also reduce your environmental impact because you're more efficient with the use of your resources. And it completely makes sense. And, you know, even when it comes to animal welfare, we can say if we're efficient and if we manage the animals well, we can improve their environment and we can offer them a more welfare-friendly system. And there are curves that exist. This is a curve from J.P. McInerney of DEFRA in the UK that said, okay, there is a curve with respect to the human's goal in terms of animal production and the animal welfare. And at a certain moment, you can go too far pushing towards your goals, but there's an optimum there. However, all of this is perfect in theory, of course, and we all know that. The problem is efficiency and production are not independent. And they could be independent, but we're humans, and we don't treat them independently. We want to do more when we can do it cheaper. Yeah, that's the truth. So that's why, and actually it's known for a long time. This is a guy called Charles Jevon, and he was based in the UK during the Industrial Revolution. And he said that it was a confusion of ideas to believe that if you use a resource economically, you will get a reduction in the use of that resource because people will expand. Yeah, and that's what he saw during the Industrial Revolution. The river was becoming more and more polluted because people, even though they had far more efficient steam engines, they were just using far more of them. Yeah, and we can see this in animal production as well. We can see that we're improving our efficiency and we're also scaling up. And that's also linked with the graph I showed you. Farmers, the numbers of farms are dropping. Meanwhile, the number of animals per farm are increasing. So the economic benefits are very clear, and this is consolidation. This is what is happening. But the negative impact is also very clear. So then we're seeing both production and efficiency having a problematic effect on the pollution and also on animal welfare, and that's why bodies like EFSA need to step in. And of course, we know that we've been trying to improve our efficiencies with broiler production. This is the pictures from the work of Zodaf in Canada, and he just looked at the breeds over the different decades, and it's very clear that we've strived towards more efficient animal production, and it's been fraught with problems. We know that, for instance, in the case of the broiler, the leg strength was a big issue for a long time until the genetics caught up there. And it's stirred on by the consumption. Year on year, we're eating more chicken. We're eating 50% more chicken than we did per capita compared to 20 years ago, and that's continuing in this line. And just to give some of the environmental impact, it's very clear here. This is a very nice picture that came from a study in Nature, where they were able to capture the emissions, the point source of emissions across Europe. And what you can see is there, and the emissions I talk about are ammonia emissions. And what you can see is that all these spots, all these dark spots, are exactly where the main intensive livestock production systems are. And you can see clearly the Netherlands and Belgium didn't avoid this either. And of course, yeah, it's a problem, and that's why we have these nitrogen issues in Belgium at the moment. And that's another picture on the right showing the amount of rivers contaminated and groundwater contaminated with nitrogen. And it's only 1 in 25 rivers or so in Belgium which is below these critical threshold of nitrogen. So it's difficult, and that's what the government is dealing with, and that's why the farmers are protesting. In terms of welfare impact, yeah, I don't want to spend too long on this. This is what Virginie was talking about, but it's a problem across Europe. This bar chart here shows the stocking density, and what it's really showing is that the farmers in these member states are not able to move towards a higher stocking density because they can't demonstrate good welfare, and actually that's in some of those places where most of the chicken in Europe is being produced. So it's a challenge, and how we're responding in Europe, and I'll take the case of Flanders, so the government measures currently are twofold. One, to reduce the number of farms, and therefore farmers are up in arms because of that. And the second is a technological approach, yeah? And that's where we think the whole PLF thing in the future is going to have a big impact. So we try and deal with the two aspects, the emission aspect, the environmental aspect, and also the welfare aspect, because it's not possible, like I showed you previously, to just take them separately. You have to combine it, integrate it into one approach. And that's where we see precision livestock farming having an impact there. And while nowadays it's becoming more and more common, and it's really interesting to see this explosion in researchers and companies getting into this field. And it's not just about the sensors and the technology, artificial intelligence and so on. It's really about trying to support the farmer with the right data so he can make more objective decisions. But it's really a challenge, and I'll give you some overview of the struggles that are there in a few moments. And yeah, it's slowly moving in a good direction, I would say. In terms of what is the underlying thing, so this is a scheme that we use in our research group. It's about control scheme, but I see a similar type of ideas also published in the literature. And there, if the animal is the main process, we try and monitor the inputs and outputs. And one of the outputs could be the behavioral response or the production response of the animal. And of course, we link with the different disciplines, but it's mainly focused on translating information from sensors into usable data for the farmer or other stakeholders. So what we often find ourselves doing is trying to process data from cameras, microphones, other devices into usable information. And this usable information needs to go to the stakeholder. So it's not just the farmer that will find this interesting. Of course, there are other members on the supply chain that can utilize this data. And in some way, we're also trying to search for who this data creates the most value. And of course, there's two aspects here, the accuracy and the actual value I just mentioned. That's key in this story, because without that value, we can't get the systems on the market, or out to the farmer at least. But this technology requires some understanding about the value of that information, and there's some very interesting work done by people at the University of Copenhagen talking about the value of information. And basically they say that there is two levels of processing. One level is where you process KPIs, key performance metrics or indicators, so that the farmer can make a more accurate decision. So that's one level of processing. And then there's another level of processing where the farmer actually acts on that data. He makes a decision to do an intervention. So there's two. There's one that's reducing the uncertainty in the KPI, and the other is stimulating the farmer to do an action. So if we look at just the first level of processing, we call that a basic PLF monitoring idea. And basically what we're trying to do is just derive usable indicators from available data or cheap sensors. And one example here is from a study that we did a number of years ago in 2014. It was about the following of the climate in the house, and then seeing how long that climate is outside the thermal comfort region of each of those birds, and then linking that with aspects like footpad dermatitis and other welfare challenges. And we could see that, yeah, if the birds were uncomfortable, then there was a higher risk of these welfare issues. And it just tells us that we can actually get interesting information using the cheap devices. Yeah? So using data from climate sensors. And of course, nowadays it's possible to capture that easily and cheaply using Arduino technology for circuit board design. You don't have to be the big expert anymore to try and do this, but you know, it's all possible. The thing, of course, is trying to make this valuable so that a farmer will make use of it as well. But that comes down to whether welfare becomes a valuable indicator to measure in the future. And the thing is, it's not only interesting to do monitoring like this of indirect variables, but can we monitor closely the behavior, the movements of the animals, and there maybe then we can start to manage these animals instead of just monitoring them. And this was a technology, computer vision-based technology that was worked on for many years in our research team in collaboration with a company, with the idea that this technology would quantify the behavior under different types of contexts, and then we could capture the welfare of the whole flock of birds. And it worked reasonably well. And so well that actually the company said, okay, we take it to the market, we try to sell it to the farmers. And it was able to capture things like the activity, the general activity, the occupation, where in the building were the birds moving, and yeah, where was there likely problems with the litter, for instance. And there was also other issues with like malfunctioning of the climate control or feeder line. That was all detectable with this. And this is just an idea of the kind of alarm system that it was able to we were able to produce with this. And it worked reasonably well for all different types of problems. The issue emerged when the company was trying to sell it to the farmers. They just couldn't convince them. So in 2012, already the solution went on the market with just measures of general activity and occupation, but now you can't find that solution anymore. And it's interesting because maybe it was just that this was too early, or maybe, and I think it's more likely, that we hadn't derived enough value for the farmers. So we had offered a lot of data, a lot of information, but the farmer didn't just not know what to do with it and if it really created value for him. So it was one of the early days of PLF, and now I think we have to really think on behalf of the farmer in terms of the technology that we work on. Okay, so we also developed this a little bit further. In recent years, we worked together with itavi, with the group of Pauline Kresch, working on red mite infestation, again using behavior monitoring. And there we were able to go a little bit deeper. So actually our indicators were now indicators of restlessness of birds during the nighttime, because that's when the red mite was active and caused a problem for the laying hens. Yeah, so we're able to be very specific, and therefore we thought, okay, now we go towards an indicator that can be useful for the farmer. And this is really capturing the nighttime activity. Again, it was just capturing the movement of the birds, but we were able to plot it in a way that we could get a heat map, and then that represented how restless the birds were in the nighttime. And you can see that here on this slide. And it worked very well, and we're still just refining this tool, but it's coming out very nice. But at the end of that project, we actually went to the farmers and we said, okay, we have a nice tool to detect behavior changes as a function of the red mite. We know that this is a major problem in the sector. What do you think? Would you pick this up? And their response was, yeah, it's not enough for us. We need more. Can you do feather pecking? Can you do piling? Can you do all of this? And then maybe it might be interesting. So it's a real challenge, and that's a barrier that's there. There's a lot of challenges to capture that data and go back and investigate the value that it will create for the farmers. Okay, so if we go a little bit further and we talk about what the next step. So I said the value of the information is not just about the uncertainty, but also about the actions that a farmer can make. And here I want to talk a little bit about robotics. I won't stay too long, just very quickly. And here, yeah, in the end, what motivates the farmer is everything to do with feed and growth on the farm. Yeah. When it comes to welfare decisions, like what Virginie was talking about, you know, the criteria from EFSA, and the farmer feels like he has to monitor everything, but he would, I think, most of the time prefer that something else would do it in his place, and also that something would do it without compromising biosecurity. And that's why I think that robotics actually will have a quite significant impact on the whole sector into the future. And I believe we'll see more and more of this, not just general monitoring, but actually machines running around in the buildings or on the range to try and monitor the animals. And that takes the farmer out of the loop, of course, to a certain extent, but only for the jobs that he doesn't want to do. That's what we saw also with dairy production. For milking, the farmer readily accepted, and I'm sure we'll see more and more of this happening for poultry production. It's interesting, there is this company, Octopus Robots, who are already doing it, and they're a French company, so France is leading the way there. Okay, so one last topic is the precision feeding. That we can also call that a robot, yeah? Because there is a machine that's taking action on some measurements that are taken to optimize the system. But the challenges are, I'll tell you, I could go in more detail about the research here, but the challenges are when you go to a production environment and you try to optimize the growth of these animals, the devices are not accurate enough. And this is work that was done 14 years ago, now finished off 14 years ago. But still at this moment, we can't find research where we can demonstrate the value and the value that precision feeding can bring to the poultry sector, and particularly because the devices are not accurate and not synced up in a way to deliver the value that's needed. I can go more in detail at some other stage. Maybe somebody would like to talk about this later on. And of course, there's a big risk when you try and bring things early to the farmer. This is a technology that went far too early, and it was really rejected by the sector. It's something called Flockman. I think they're trying to bring it back again. But there is a very nice write-up about how this was a little bit upsetting to the farmers when it didn't work right. So maybe in the future we'll see more of the integration of simulation tools with real-life farming. I hope there will always be the action of the farmer in the middle of the process. It's needed. It's too complex to take the actions completely out of his hands. But for sure, we will see some of those actions being taken by robotic systems in the future. So these are the take-home messages. The key ones are that we don't get far just by measuring coarse indicators of production and expecting farmers to use this data. And number two is that, in the future we'll see more and more of the robots, but we need to be careful in how we bring this to the farmer. Okay, so thanks for your attention, and questions if you have any.
Thank you, Mr. Norton. Donc, je ne ferai pas la synthèse. Je vous laisse la faire vous-même. S'il y a des questions dans la salle, droite, gauche, ici.
Thomas, yeah, from INRAE. Thank you for the presentation. You mentioned earlier in your presentation about the problem of new generations of farmers. And you also mentioned that these technologies come too early. What is the profile for a farmer in 20 years with these technologies? Is it different from the profile that we have now? Is it your son that could be?
Well, it's interesting. Yeah, I think for sure we're seeing more data, younger people that are far more interested in data. Like people who are carrying their mobile phones, like that's a basic thing nowadays, an accepted thing. But this idea that, yeah, it's not just about going out to the farm with your spade or whatever, that they can really use, it can be really considered as a data-intensive sector. I think that's the kind of profile we'll see, people who are willing to tackle this. And if I just talk about the courses we teach, in the past it was, we teach an animal production course and also a biosystems engineering course. In the past it was always farmers' sons and daughters that were in. Nowadays, most of them don't know anything about a farm. And still they're willing to jump into this. So I think the future is bright from that perspective, and that's the profile, hopefully, that we will see. Yeah.
Another question? Il y a un peu de base, pour ceux qui rigolent.
Also, if you want to ask questions about rugby, it's okay too.
Just a question. One question, Pauline Créache from Itavi. What is your position on, we are using more and more technologies, but what about environmental footprint regarding the use of those technology? What is your position on this?
So you mean with regards to the processing of the data in large data centers and this kind of thing?
Yes, it's using energy also.
Yeah, that's using energy, but I would hope that we can at least offset or even go beyond the energy that we're using by reducing the carbon footprint of the farm a lot more. No, that would be the final argument there. But I believe, we're going through a phase where we're listening to all the energy that's being consumed by these big AI systems, these large language models that need billions and billions of parameters. We're not talking about that here. We're really not talking about. We're talking about small, efficient models that can run on the farm. And therefore, I think we don't have to worry that much about these kind of issues. I think general society should worry about it because we're all using ChatGPT and so on and so forth. But yeah, for what we talk about here, it's a different story. That's my view on that.
So last question with Nicolas.
Well, thank you, Thomas. I remember maybe a few years ago when discussing PLF acceptance by the farmers and the consumers, there was a discussion about what can PLF do to help us in less intensive environments, because basically what is currently requested by the consumer and the society is possibly not the full intensive environment. So we would like our chicken to go outside, so what can PLF do in an outside environment for the farmer?
Yeah, and you're talking about poultry production, of course. I mean, it's far more challenging with poultry than it is with, for instance, dairy cows, where you can attach a device to a cow, which is a high-value animal, and therefore you can, you don't have to be so careful about making it very, very cheap. That is a challenge. I mean, in terms, for instance, we see people starting with just the use of the range, like leaving the building, counting the birds as they leave through the pop holes. I mean, that's a starting point, right? And that's some way to measure how the system is being used. But yeah, we can potentially, I can propose a whole pile of things, but I mean, we see like the use of drones being used a lot more. Has it a possibility for poultry production? I know that, yeah, predators are obviously an issue. Maybe the drone would be perceived a predator. But I think there is a whole pile of different opportunities that need to be explored and haven't yet been explored. Yeah, it's an open field.